Okay, good evening. Good evening. Okay, good afternoon, guys. I'm very sorry about the lack of me keeping my word. I had said that I would do grade 9 GEC, but I couldn't, guys. I couldn't. Today was so busy, so busy. So we have grade 9. No, guys, sorry. All these people that are saying grade 8, grade what, 11, grade what. I'm not going to do grade 8, grade 11, grade 12. We are doing grade 9, and we are looking specifically at GEC. Okay, so I am actually going to, for this afternoon, look at GEC 2023, the grade 9 paper, all right? In my previous live, I've been doing grade 9 GEC 2024, but I'm going to turn my attention away from 2024 today, and I'm going to look at 2023. And I'm going to pick it up exactly here in this question, all right? In this question specifically, all right? So, yeah. All right, we're going to look at this question specifically. Hello, Shayna. As I said to you, grade 11, Shayna, I'm going to be attending you tomorrow. All right? But I see you there. I see you there. I see you there indeed. Okay? All right. So let us go to question number 4 of this GEC paper. All right? Yeah, 2023. The important topics, guys, let me just turn your attention to this, because some of you are asking that. Just wait. Let me tell you the topics that will be assessed in the paper, so that you guys are aware. Right? Can you see what's on your screen? I hope you can. So the important topics that will be assessed in tomorrow's test, guys, are these ones. This is the exam guideline for GEC paper 1. This is the exam guideline for GEC paper 1. So the topics that are going to be assessed are the ones that you see on your screen. They're going to be assessing whole numbers. That means the properties of numbers, okay? Properties of numbers. So you guys need to know the whole entire number system, and you must be able to distinguish the properties for natural numbers, whole numbers, integers, rational numbers, and irrational numbers. I'm hoping, guys, all of you can distinguish between what a natural number is. Natural numbers are numbers that start at 1, increase by 1 all the way to infinity. Those are natural numbers. 1, 2, 3, 4, 5. They go up by 1. Whole numbers are numbers that start at 0 and increase by 1. 0, 1, 2, 3, 4, 5, na. Integers, on the other hand, are positive and negative whole numbers. Negative 1, 0, 1, 2, 3. It includes the family of negative numbers. Rational numbers, we know, are numbers that can be written as a fraction. Numerator and denominator must be integers, and the denominator can never be 0, because remember, the minute a denominator is 0, we know that that fraction is undefined. So please, these are the topics, guys. Numbers, you must know everything. Distinguish between an irrational number and a rational number. Know everything that has to do with your numbers. Then the next thing, multiples and factors. You must know how to use prime factorization of numbers to find the what? The LCM and the HCF. You must know that, guys. How to find the LCM and the HCF using prime factorization. This is for grade 9, guys. This is for grade 9, guys. GEC tomorrow. Then solving problems. You guys need to solve problems of ratio, rate, direct proportion, indirect proportion, and financial maths. Remember, guys, in financial maths you have compound interest, simple interest, you have VAT, you have commission, you have the hire purchase, and you also have exchange rates. So these are all under financial maths. So guys, when we are talking about whole numbers, those are the topics that basically cover whole numbers. Okay? All right? Integers, you must know integers. Everything about integers. How to apply the commutative, the associative, and the distributive properties for addition and multiplication. Additive and multiplicative inverse for integers. How to perform calculations involving all 4 operations with integers. And then how to perform calculations with all 4 operations that involve squares, cubes, square roots, cube roots of integers. These are the things you need to know under integers. So guys, you must know whole numbers, everything under whole numbers. You must know integers, everything in integers. Okay? Yes, the live is beginning now because, guys, things happened. I could not start the live at 1 p.m. So please have a little bit of mercy. Some of you are angry because you didn't see me at 1 p.m. I had a problem. Okay? I had a problem. So forgive me. I'm sorry. I didn't keep my word. Grade 9, guys. Grade 9. Then exponents. Guys, you must know your laws of exponents. How to apply those laws. How to apply those laws. These are the things you need to know for GEC. Okay? Then number patterns. You must know number patterns, guys. Grade 9s, you must know number patterns. Okay? Very important. Very, very important. Exponents and number patterns, you must know. You must know and know very well. Okay? So far, I hope we are together as far as what we need to know for our grade 9 paper 1. Guys, I'm not doing grade 8 at all. So if you are here for grade 8, grade 10, grade 11, grade 12, I think you should not be here in this live. I'm preparing learners for GEC tomorrow. Okay, so you need to find another way of preparing if you are writing another grade. Grade 9 right now is my focus. Paper 1 for GEC tomorrow. Okay, so yes, number patterns. All right, as I said. Let's turn our attention to the next topics that we need to know. Algebraic expressions, please, guys. So under number patterns, you must also be able to find the rules. You must be able to look at diagrams that have different things and interpret the number patterns. You must be able to look at all of those things. Okay. Then you must also know how to change certain things. All right. Get the terms, get the positions of the terms, and so it goes. Algebraic expressions, guys, everything under algebraic expressions. Identifying and classifying unlike terms in algebra. Recognizing and identifying coefficients and exponents in algebraic expressions. Recognizing and differentiating between binomials, trinomials, and monomials. How to expand and simplify. How to factorize. And how to solve equations. These are the things you need to know for tomorrow's paper, for GEC paper 1. Okay? Right? Then the last part of what you need to know for your GEC paper tomorrow is functions and relationships. You must know, guys, how to do what? You must know how to find input and output values using tables, flow diagrams, formula, and equations. You must know how to interpret, determine, and justify verbally your flow diagrams, tables, formula, equations, and also the graphs on a Cartesian plane. Graphs on a Cartesian plane. You must know how to sketch your linear graphs. You must know how to find the equation of your linear graph. You must know how to plot the points using the dual intercept method and the point by point. You must know how to do these things. All right. So that is grade 9, paper 1 GEC. These are the topics that you guys need to be on the know-how for tomorrow. Okay, and then obviously this one is for natural science. I will go there and I will show you for natural science. Basically, those are the topics, but I mean, guys, that is just natural science. Okay, let's back up a little bit. So this is what I said. This is for the mathematics. So even though it's multiple choice, the topics, remember, it is only multiple choice usually for the first 50 questions. GEC is usually multiple choice for the first 50 questions. The first 50. Okay, only the first 50. It's not all multiple choice. If you have a misconception of thinking it's multiple choice for the first 50. Okay, all right. This is a past paper, and I'm sure you guys can see that for this particular past paper, let's look at this one. For this particular past paper, it was multiple choice all the way for the first 60 questions. Okay, yeah, 60 questions, sorry, not 50, my mistake. The first 60 questions was multiple choice. Then section B, the last 15 marks, is not multiple choice, but you need to actually do calculations, right? And there's space provided to do calculations. So yes, it's the first 60 questions are multiple choice, okay? And then the last few questions, all right, for 15 marks are not multiple choice, but it's things that you need to actually do what? You need to write and solve so that we can show the working out on the piece of paper, the booklet that has been provided. Okay, so first 60 questions, grade 9 GEC is multiple choice. Then the last 15 questions, that has been the tradition for the past 2 years, that the first 60 questions, they do multiple choice, and then the last few, they usually go ahead and they have us, answering things in the answer book. Okay? So I hope you understand that situation. All right, so let us begin. This paper, guys, is 2023, all right? 2023. This is not the test you'll be writing tomorrow. This is just an example of a test that was written last year. Okay, so if you look at this one, as we started off, which word best describes negative square root of 3? A, rational. B, irrational. C, undefined. D, non-real. 2024, I'm going to finish off the 2024 paper, guys, this evening at 9 p.m. This evening, I'm going to finish off the 2024 GEC paper, okay? I'm going to finish off the 2024 paper, I'm going to finish off this evening at 9 p.m. So don't ask me again. 2024 GEC paper, I've already done question 1 up until I think 40 something. All right, so what is left is the remaining questions that are there. I'm going to do that this evening, the 2024 GEC. All right, so I'm starting 2023 today, now, all right, and we'll see how far we can go with the 2023. So the word that best describes negative square root of 3, I hope we all understand that it is not A, it is definitely B, it is not C, and it is not D. Why is it B? Guys, please, by now, you should all know that an irrational number is a non-terminating or non-recurring decimal number. So what we do is you grab your calculator, guys. Always check these things. Go to the calculator and press negative square root of 3. When you have pressed, say equal, then you see this. You press SD in your calculator. Then look at the decimal numbers. When I say to you the decimal is non-terminating, what does that mean? It means the decimal does not stop 732050808. These decimal numbers are limited by my calculator. But if the calculator was even bigger, you would see more numbers come after this 8. That is the last number here. So this means the decimals are non-terminating. A lot of numbers that don't end after the decimal. 2, they are non-recurring. What does non-recurring mean? It means the numbers do not repeat having a pattern. So 732050808. Okay. Now someone might say, but sir, look at this 0808. It's repeating. No, guys. Look, the numbers are not repeating. After the comma, we have 732. That's a pattern of number 732. After that, it's 05. There's no pattern of repetition here. So in other words, when we say non-recurring, we are saying there is no pattern of repetition. Okay, I hope you understand. Okay, hearts for Boy Pelo. I'm glad. Yosa, I wrote today. I found it easy. Thanks to you. You're very welcome. I'm glad you found your paper easy. These are things that make me happy when I see them in the comment section. You're very welcome, Boy Pelo. I'm happy that it was able to assist you in your paper that you were writing. So for my GEC kids, okay, this here, guys, is definitely non-recurring and non-terminating. So therefore we say the answer is B. It is irrational. Thank you, Awanda, for the rows. Let's move on to number 2. Given 12, 18, and 27, what is the LCM of the numbers? Remember, we said we must know how to find the LCM using prime factorization. Thank you, Joe, for the rows. So prime factorization means what? Our 12, our 18, and our 27. It would be nice if we can get the prime factorization of 12, 18, and 27. In grade 9, it's very easy for us to get the prime factorization. Thank you, Regan. We just write 12 is equal to, and then we press shift, we press C fact, we get 2 squared times 3. We write 8. 8 is equal to, we press shift, we press fact. Thank you, Ndlovu, for the rows there. We get 2 to the power 3. Yo, not 8, sorry. 18. Please, guys, make it a point that when you write down these things in your calculator, you write the right thing, not the wrong thing. 18 is 2 times 3 squared. Then lastly, thank you so much, guys. Appreciate the gifts. Then lastly, 27. We say 27 equal to, then we press shift, we press fact. We get 3 to the power 3. So the letter method is not even needed. We can prime factorize just simply using the prime factors using our calculator. Then from there, we check for the what? The common base that has the highest exponent. So 2 is a common base for the first 2 numbers. The common base is 2. Which one has the highest exponent? It is 2 to the power 2. Then we look at 3. 3 to the power 2 and 3 to the power 3. Which one has the common base with the highest exponent? It is 3 to the power 3. Not 3 to the power 2 and not 3. Then we multiply these two. 2 to the power 2 is 4. 3 to the power 3 is what? Is 27. From the calculator, what's 4 times 27? It is 108. So what we simply then do is we go to the option. What is the LCM of the numbers? We got the number. It's 108. So the answer is B. Moving right along to the next question. What is the what? The LCM of what? 8 over 30 and 12 over 36. The what? The HCF. So we are going to first look at the numerators, 8 and 12. When we see 8 and 12, we are going to first write down the prime factors of 8. From the calculator, we get 2 to the power 3 for 8. Okay? What did I do, Alibaba, to get the answers in the calculator? Ali, 12 needs to be written as a product of prime factors. So what I do in the calculator, Ali, I say 12, you type that in, there we have it, 12. You press equal. Then you go press this word shift here, and then you go press this word fact. You get the product of prime factors, 2 squared times 3. So that's what I did for each number. You press 18, you say equal, you press shift, then you press fact. You get 2 times 3 to the power 2. Then you take 27, you do the same thing. You go to your calculator, you press 27, you press equal, you press shift, you press fact. You get 3 to the power 3. So this is how I get all of my respective number bases. Then after that, for the LCM to be identified, all right, I always post this on YouTube. The link is in my bio. You do this. You take the common base from these numbers that has the highest exponent. So you can see that 3 is a common base, 3 is also there as a common base, and 3 is also there as a common base. So what you do is you take the base with the highest exponent. Which one? It's 3 to the power 3. Okay? Then you look at base 2. Base 2 here and base 2 is common for these two numbers. So you take the common base with the highest exponent, it's 2 squared. Then you multiply those two, you get 108. So the answer is 108. Let's move on, guys, to number 3. If you have another calculator, then Alibaba, I'm sorry, I think I can't help you in that situation. The thing is, the recommendation for learners, for instance, when we teach them, is always encourage them to get a Casio calculator. It makes life very easy. Okay, given 8 over 30 and 12 over 36, what is the highest common factor? So we are still going to use prime factorization to actually get the factors of 8 and 12. Let's first look at the numerators and get the factors of the numerator. So for 8, the prime factor, if we say 8 is equal to shift fact, we get 2 to the power 3. For 12, if we say 12 is equal to shift fact, what do we get? We get 2 squared times 3. Then let's check. What is the highest common factor for these? Now, guys, for the highest common factor, we always choose the common base. But this common base has to be common for all 3. It can't be common for some. It has to be common for both the numbers. So for 2 to the power 3 and 2 squared times 3, which one is the common base that has the lowest exponent? Okay, it is 2 squared. The common base is 2, but which one has the lowest exponent? Because when we look for highest common factor, we check the common base with the lowest exponent. So between 2 squared and 2 to the power 3, it's definitely 2 squared. 3 is not common, so it is not included in my answer for the highest common factor. Okay, so the answer we get then for the highest common factor between 8 and 12 is 4. This is for the numerator. Let's go to the denominator. We have 30 and 36. 30 and 36. We do the same thing. What are the prime factors of 30? We go to our calculator and we press 30 is equal to, then we press shift, then we press fact. We get 2 times 3 times 5. 2 times 3 times 5, 36. We press 36, we say equal, we press shift, we press fact, we get 2 squared times 3 squared. 2 squared times 3 squared. Then for highest common factor, guys, what did we say? We choose the common base with the what? With the lowest exponent. But be common for all 2. 2 and 2 are common. We are going to choose for the highest common factor 2. Just 2, not 2 squared. 3 and 3 are common for both, so we choose 3 to the power 1, which is 3. 5 is not common. It cannot be included in the highest common factor. So that means the highest common factor is 6. That is my denominator. The numerator was highest common factor was 4. The denominator's highest common factor was 6. Okay. Then we conclude, guys, and we say that the highest common factor between these two fractions, remember our numerator was what? Was 4. Our denominator was what? Was 6. But then what is 4 divided by 6 when it is simplified? That simplification of 4 over 6 gives us a beautiful answer of 2 over 3 when we simplify the fraction. 2 over 3. So that is why we say that the highest common factor between 8 over 30 and 12 over 36 is actually a 2 over 3. All right. What did we do, guys? We found the highest common factor between the numerator values. We got that highest common factor. Okay. We find the highest common factor between the denominator values. We got that highest common factor. Then we took the numerator and the denominator. We wrote it as a fraction, which is 4 over 6. Then we simplified to get 2 over 3. So those who are saying, sir, you can use the ladder method. Remember, guys, using the ladder method is going to be a time-consuming way of getting the product of prime factors. That is why I say to you, the calculator is there for you to just simply write down your numbers and get the product of prime factors, and then you are able to get those factors and get the answer. All right. So sorry, guys, I'm going to move on to the next question, which is question number 4. Which graph represents direct proportion? Thank you, Michelle. You guys are very kind with your comments, some of you, but not all the time. Which graph represents direct proportion? Is it A, this one? Is it C, this one? Is it B, that one? Is it D, that one? Okay. Now, guys, direct proportion, let us remind ourselves. What is direct proportion? Direct proportion is the comparison of two quantities, okay, where one quantity whereas one quantity increases, okay, increases, the other also does what? Increases. Or vice versa, guys. As one quantity decreases, the other one decreases. So my y-axis represents one quantity and my x-axis represents another quantity. For this graph, the reason why we're saying it is C, as x increases, what is happening to y? Y is also increasing. We also know the following: the product between, the ratio between the quantities is constant. The what? The ratio between the quantities is constant. What do we mean by constant? It means that the ratio between the quantities remains the same. The ratio is the same. So it is only this graph which is a representation of direct proportion. Okay, so it is C. The answer is C. Which graph represents direct proportion? This is it. It is C. Let's move on. Let us move on. Let's move on. A car traveling at 120 kilometers per hour covers a distance in 2 hours 45 minutes. The car then travels the same distance in 3 hours and 12 minutes. The question is being asked, what is the constant speed that the car travels? Okay. A car traveling at 120 kilometers per hour covers a distance in 2 hours 45 minutes. The car then travels the very same distance in 3 hours and 12 minutes. And the question is, what is the constant speed that the car travels? All right. Now, this is a very simplistic calculation. And to help us out, we have this beautiful diagram here, which we call our DSTV satellite dish diagram. Distance, speed, and time. Whenever we want to calculate distance, we take speed, we multiply it with time. Whenever we want to calculate speed, we take distance and divide it by time. Whenever we want to calculate time, we take distance, we divide it by speed. Okay, I hope that makes sense. So now what they want here is, what is the constant speed that the car travels? Okay. I know DSTV is crazy, right? So that's why I call it DST, and then I usually say this is like a V. The triangle, at least this part is like a V, right? I know it's a triangle, but I mean it's like a V. So that's how I remember. My learners remember DSTV. All right, hope that makes sense. So if we want to calculate the constant speed, let's first check. It's saying here, a car traveling at 120 kilometers per hour covers a certain distance in 2 hours 45 minutes. Now guys, we have minutes here, and we would rather not have minutes. We must convert these minutes to hours. All right, then it says the car then travels the same distance in 3 hours and 12 minutes. You see, once again here, what do we have? We have hours and minutes. So we need to convert certain things. So let us first go ahead and do what? Let's go and calculate. Okay. For this first situation, we are told a car traveling at 120 kilometers per hour. What is 120 kilometers per hour? 120 kilometers per hour is what we refer to as the speed. Then, what else do we have? Time, which is 2 hours 45 minutes. But as I said to you, let us convert this 2 hours and say plus. Take the 45 and divide it by 60. Why are we dividing the 45 by 60? Because how many hours are there in a minute? There are 60 minutes in 1 hour. Sorry, how many minutes are there in an hour, guys? That's what I mean. How many minutes are there in 1 hour? There are 60 minutes. So we take 45, we divide it by 60. That should give us 2 hours plus what? Plus a 0.75 from 45 divided by 60 when you use your calculator. That means we get 2 hours, 2.75 hours. That's what the time is when we just write it purely in hours. So that means we can calculate this distance, this certain distance that apparently this car is traveling. We use our beautiful formula here. This guy, thank you, Mkolisi, DST, we know about. So when we want distance, we have speed and time. How do we calculate the distance? We simply say D, meaning distance, is equal to S times T. S times T. Distance is equal to S times T. The S is next to the T, so that's multiply. If you want to calculate distance, it's speed times time. If you want to calculate time, it's D over S, so it's distance over speed. If you want to calculate speed, it's D over T, distance over time. So just remember that. So then when we multiply our 120 kilometers per hour times by 2,75, we get a beautiful answer. Little Uzi is saying we get 330 kilometers. Thank you so much. That is the distance. But remember, they said the car then travels the same distance. So this car is going to travel the very same distance in how long? In 3 hours and 12 minutes. The question is, what is the constant speed that the car travels? So now we are going to be interested. What is the speed that this car is traveling in? Okay, so we want S now, but what do we have as well? We have the time, which is 3 hours and what? And 12 minutes. So once again, we are going to take the 12 and divide it by 60 to convert the minutes to hours. Then it means what? We are going to say 3 plus what? How are we going to do this? 12 divided by 60, thank you, love, Charmaine. It's what? 0,2. Is it, guys? Thank you so much, Lindy. 0,2. So that means we have 3,2 hours. All right. So the person was asking me, how did I get 2,75? My guy, I was told 2 hours 45 minutes. The minutes must go. So it's 2 hours and 45 minutes, which means we take the 2 hours plus the 45 minutes. But if we want to convert minutes to hours, what do? We take the minutes, we divide by 60, because there are how many minutes in 1 hour? There are 60 minutes in 1 hour. So 45 divided by 60 gives me 0,75. Then I add these two, I get 2,75 hours. Then I can substitute, get the answer for distance. Now that I have the distance, I am interested in the speed that this car is traveling. If it takes how much time? 3 hours and 12 minutes. I have to convert now these minutes to hours. I divide the 12 by 60. I get 0,2. That's 3 hours, 3,2 hours. Then what do I want? I want to also include in my calculation the distance of 330 kilometers. What do I need? Speed. I go to my DSTV triangle. I want what? Speed. What does my DSTV triangle say? If you want speed, it is calculated by saying distance divided by time. Are we together, grade 9s? Distance divided by time. So I'm going to say D over T. And then I substitute 330 kilometers divided by time, which is 3,2. Then I get a beautiful answer like Natty2 Goated says. Natty2 Goated says I get an answer of 103, what? 125. But remember, our answers need to be rounded off. If I'm looking at my memo, I'm like, hey, the answer needs to be rounded off indeed, as per the instruction would say, to 2 decimal places. So the 5, what does it say to the 1, to the 2? 5 and more means we make that particular 103, this 2 will go up by 1. So it's 103,13 watt, kilometers per watt per hour, because it's what? It's speed. So therefore, if we go to our options, which one is this option that is correct? It means A is our answer. 5A. There it is. I select, move on to the next question. The next question here says, 5,265 Rand is invested at 12% per annum compound interest for 24 months. Just a moment here. Someone is saying here, please do higher purchase. Guys, can I just ask you to do the following? I have done higher purchase in my YouTube channel. Go to my YouTube page, guys. The link is in my bio. You go to my YouTube link, you click on the link, it should send you to my YouTube page. you should scroll down. There is a video that I did of grade 9, just higher purchase on its own. I explain higher purchase. And then after explaining higher purchase, I explain it using problems. Go and check it out and go and learn what higher purchase entails. That's what I can say to you guys, because unfortunately here in these GEC papers, there's no higher purchase question. Go and check it out there. Thank you so much. Let's go. 5,265 is invested at 12% per annum compound interest for 24 months. How much interest will the investment earn in 24 months? So what type of calculation is this? Look at Michelle's answer there. Michelle is the GOAT. Michelle is the GOAT. There, the pinned attempt. 5,265. Michelle, you just wrote 5,262. So please, when you are answering the GEC, make sure you write out the values correctly. So that's just an error there, but I get the point. 5,265 is invested at 12% per annum compound interest for 24 months. So what does that mean? Compound interest, we have a formula for compound interest. It is this one. A is equal to P brackets 1 plus I brackets to the power n. Tomorrow when you do the GEC paper, you must know these formulas off by heart, because in the GEC paper itself, you won't see these formulas. You must know them. So A is equal to P 1 plus I to the power n. This is for compound interest. And then A is equal to P 1 plus I times n. This is for simple interest. So the calculation we have before us is not saying simple interest, it is saying compound interest. Now, what does A mean? A means the final value, the amount that you have after some years have passed, after a number of years. P is the amount you have at the beginning. I is the interest rate, and it is a decimal number, so that is why we always take the percentage, we divide it by 100 to get the decimal number for interest rate. N is the number of years. So if I look at this situation, this amount is invested at 12% per annum compound interest for 24 months. So what is the value of A? I don't know, because the question is saying how much interest will the investment earn in 24 months. So we need to calculate A in order to find that. So A we don't know yet. P, the amount at the beginning, we have it. P, the amount at the beginning, it's 5,265. Okay. I is basically the interest rate, all right? But that interest rate, like I said, it's a decimal number. So what do? We take that interest rate, we divide it by 100. We get 0.12. That is our decimal number. Okay. I know Nati quoted, you can actually type shift you can actually press in the percentage, but it's important for you guys to distinguish between the decimal number interest rate, because I as the interest rate is a decimal number, it is not the actual percentage, all right? So we need to distinguish between I, the interest rate as a decimal number, and R, the interest rate as a percentage, okay? N is the number of years. So we need to convert this 24 months to years. What's 24 months into years? We need to divide by 12, so that means 2 years, okay? Now that we have our conversions sorted and fixed, we can go and substitute in the formula. A is equal to P. The P value, all right, is 5,265. 5,265. 1 plus the I, the interest rate, 0.12. Thank you, Zaki, for the rows. I really appreciate it. N is 2 years to the power 2. You grab your calculator. You just type all of this in. Okay? You type all of this in. 5,265. You open the brackets. There they are. 1 plus 0.12. You close the bracket. Then there the exponent, all right, and then 2. Then you press equal. You get 6,604 rand and 416 at the end. But wait a minute. We might think that we are done. The question was very clear that what they want is the interest that was earned. Okay? The interest that was earned, meaning the amount of money that was actually made or earned. So what you have to do to calculate that interest that is earned is interest that is earned has a formula. You take A, your final amount, and then you subtract P, your initial amount. Okay, okay, so 4,42 minus the P, 5,265. So then the answer there will give you 1,339 rand. That should be 42 cents. That is the money that was made. Remember, this person invested this amount. This amount was an amount that this person had. The minute interest was added to this amount, it accumulated and it became this amount. All right? But the difference between this amount and that amount is this one. This is the interest that was earned. Okay? Okay, so let me just, I'm going to have to pause here. Okay, sorry guys, I had to change venue. I had to move venue. I had to move. You're not all failing. What nonsense are you guys saying in the comment section? What rubbish. Guys, please avoid this negative language that you guys are using in the comment section. Okay, please, please, please. I had to change venue. So that's why there was silence. Okay? There's always silence before something great happens. Okay, let's move on to the next question, guys. So I hope you understood this one. Okay? Yeah, that's why we say the answer is D. Please read the question. This answer would have been different had they say, if they hadn't said how much interest will the investment earn. This was the key word that made us then make this step of taking the final amount and subtracting P. Those who are wondering when will I be finishing off GEC 2024, I'll be doing it tonight at 9 p.m. GEC 2024. Remember, I had already started GEC 2024. I just have to do the last few questions. All the other questions for GEC before that question where I'll be starting are already, they are already in my YouTube page. So I will go, you can go and check those out, the videos that I did for the first few questions, all right? But I think I'm picking it up for 2024 at question 40 and I'm going to continue on from there. Okay, that's where I'll be starting at 9 p.m. GEC 2024 I'll be doing at 9 p.m. For now, I'm just doing 2023. Okay, let's move on to the next question. YouTube page, you can find the link in my bio, guys. The YouTube page is called Maths is a Game. It's just like what you see the name is. Okay, the link is in my bio. Okay, yeah, then after you put that 12 over 100, just press SD. Go in your calculator and press SD. If your calculator, after putting a fraction in your calculator, you get that, just make sure after that you press SD. Okay, please guys, just press SD. 12 divided by 100, you get 3 over 25. Go to this button, this one, S to D. There it is, you see, not comma 12. Okay, so I hope it makes sense. Okay, let's move on. Negative 7 times 11 in brackets times 4. Which expression represents the associative property? You remember I said we need to know the properties of numbers. Associative, look, negative 7 times 11 times 4. Is it negative 7 times 4 plus 11 times 4? We are talking about the associative property. No. Is it negative 7 times 4 times 11 times 4? No. Is it negative 7 times 11 times 4? Look at this. Negative 7 times 11. This is negative 7 times 11. The brackets are for the first two products. But then here, the brackets are for the last two products. So associative property has to do with exactly that. A times B times C is equal to A times B times C. A times B around the first two, B times C in the same order around the last two. That's associative property. Okay, so C is our answer. That is associative property. But if we come here, 4 times negative 7 times 11, that is not what we mean by associative property. So it is C. Okay, let's move on to the next one. Okay, 3 into negative 2 plus 6 minus 2 into 5 minus 4 plus 1. Well, obviously you can put all of this in your calculator and probably just get the answer because it is GEC. But if we were talking about step by step to getting to the answer, because remember some of these questions, guys, you need to just get straight to the point. Don't waste time and don't allow yourself to stay too much, right, in a question, especially if it is clear. So look at this. If I did this, let's say I put all of these into the calculator, minus 2 brackets into 5 minus 4 plus 1. I close the bracket. What do I get? I get 8 as my answer. Do you see that? The answer just pops out from having put in the values. So if I have numerical values that I can just punch in, It's straightforward, guys. It's to the point. So the answer here is what? It's B. It's as simple as that. If you were calculating step by step, and let's say you had to get marks for it, then you would say 3 minus 2 plus 6 minus 2 into 5 minus 4 plus 1. You apply who? Bed mass, or board mass as they call it. You look at the brackets. 3 stays outside. Minus 2 plus 4 gives us 4. Minus 2, you look at what's in the bracket. What's 5 minus 4? It's 1. What's 1 plus 1? It's 2. Then what's 3 times 4? Brackets mean multiply. So you have 12 minus, what's negative 2 times 4? It is 4. 12 minus 4 gives you 8. So in other words, you would actually get the same answer if you were actually going ahead and doing this step by step, applying bed mass. Does that make sense, guys? I hope it makes sense. So that's what you would then do. Okay. Let's move on to the next one. What are the additive and multiplicative inverses of negative 2? Now, when you say additive inverse, you mean what you add to another number so that you get 0. That's what we mean by additive inverse. So they're asking what is the additive and multiplicative inverse of negative 2. So let's start with the additive inverse. So negative 2, what do we add to negative 2 to get 0? What do we add to negative 2 to get the 0? Because by additive inverse, we are saying what is that number that we are going to add to negative 2 to get 0 as our answer. Okay, so we know that the answer is 2. So the additive inverse of negative 2 is 2. Let's come here. 2, this one is out, this one is out, 2. So we have A and D as a possible option or choice. So for additive inverse, what do we mean by that? That number we are going to add to negative 2 to get 0. It is 2. Multiplicative inverse. What do we mean by multiplicative inverse? That number that we are going to multiply to negative 2 so that we get the answer 1. That number that we multiply to negative 2 to get positive 1. That number that we multiply to negative 2 to get positive 1. What is that answer? Negative half. Right? So this is the multiplicative inverse of negative 2. It is a negative half. All right? So therefore our answer, is it A, 2.5, or is it D, 2 and negative half? Well, guys, you can see 2 and negative half. It is D. It is D. I repeat, additive inverse is that number that you add to another one to get 0. Multiplicative inverse is that number that you multiply to another so that you can get the answer 1. So the multiplicative inverse here is negative half, whereas the additive inverse is what? 2. Okay, let's not forget that for future. Let's go and look at number 10. Now once again, guys, you come to this problem, maybe if your calculator is here, you can punch all of this in without actually working it out step by step. You go to your fraction mode, there it is. You press 2, you write brackets. You write minus 3, you close the brackets. You follow it up with what? Minus, you open another bracket. You press 5, you close the bracket. Then you follow it up with minus. You press 4, you close, open another bracket, and you say 6 divided by 8. Because this is 6 divided by 8. You close the bracket over. At the bottom, you write 5 minus 6. 5 minus 6. There it is. Just check if everything has been put in the calculator correctly. You press equal. There's the answer. Goat. 14. There's the answer. We don't waste time. we move on to the next question. You see, or you can do it step by step, of course, as you know, applying who? Bad mass. How would you apply it step by step? You have 2, the minus 3, minus 5 in brackets, minus 4 into bracket 6 divided by 8, close the bracket, over 5 minus 6. Does that make sense? So then you start with B, brackets, minus 3, the 6 divided by 8. You see these things? Okay, I hope it makes sense, guys. So because it's multiple choice, we can do this, guys, because it is multiple choice. Don't waste time. Okay, don't waste time. Yes, guys, it's 2.5 for everyone. Everyone knows it's 2.5. Look at this one. Okay, this one we know we can solve. Okay, square root of 49, we know it's 7. 2 to the power 3, we know it's minus 8. The cube root of 216, we know that is 6. And then that divide by 3, that is there. So 7 minus 8 is negative 1. The 6 divided by 3, 3 goes into 6 how many times? 2 times. Then minus 1 plus 2 is 1. But same thing, we can grab our calculator. Those who are saying they're coloring to bona the cover page, GEC 2023, that is the paper. 150 minutes, okay, yeah, 2 hours, almost 2 hours and 30 minutes, that's it, okay. So same thing, you see, negative 1 plus 2, you can grab, don't waste time, look, grab the calculator, because we want the answer, that's all we want. Say square root of 49 inside, minus 2 to the power what, 3, plus the cube root. Guys, this is only applicable if this is what? If this is multiple choice. Please, if it's multiple choice. But if it's not multiple choice and it's a question where we have to write down the steps, then you need to show the steps. But I'm saying if it's multiple choice, look at that, equal. There, you see? 1 is the answer. Okay, 1. Okay, let's come here. Even this one. We can put all of this in the calculator and get the answer. Really and truly we can. Alright, even though I'm going to show you the step by step, we have a square root and inside we have the cube root of negative 64 plus a 5 over 4 squared plus 3 squared. So check me out, do this step by step. Let's keep the big square root and let's focus on what's inside. What is the cube root of negative 64? You can find this on the side in the calculator. It's actually equal to negative 4. Then you have plus the 5 there over. What's 4 squared? That's 16. What's 3 squared? That's 9. Guys, that's how you would do it step by step so that you show the steps and you get the marks for the individual values that you get. Okay, does that make sense? Then you have negative 4 plus 5 there at the top. You have 1 over. What's 16 plus 9? It is 25. But remember, there's a square root there. Now you can split. Okay, you can split because you have 1 term at the top, 1 term at the bottom. So the square root of 1 over the square root of 25, that gives you 1 over 5. Which answer is that? It is C. You can put this all in the calculator, you'll still get the same answer without having to do the steps. I just need you to know and understand that the steps, if we were asked, all right, for the steps, you would show the steps and you would be able to get to that answer. Let's move on to the next question. Simplify. Simplify. A cubed times a squared c. A cubed times a squared c. What does this mean? A cubed times a squared c, we know the laws of exponents. Guys, we have been inundated with the laws of exponents. We know that when we are multiplying the same base, we keep the base, we add the exponents. So look here, we have a cubed times a squared c. So that means the a and the a, we are going to keep the base for the a for the multiplication of a, and we are going to add the 3 and the 2. The c is just going to chill there next to the a to the power 3 plus 2. That gives us what? A to the power 5c. That is the answer. Okay? a times a squared, we keep the base, we add those exponents of a. C chills next to the a. We add the exponents, we get a to the power 5. The c chills next to the a to the power 5. So the answer here is what? It's a. Let's move on, guys. I have no time. 4 to the power x plus 1 over 2 to the power x. You see, now we can't avoid using, we have to actually show our steps here so that we can see what we are doing. 4 to the power x plus 1 over 2 to the power x. Here we have a division of bases. 4 is a composite number, so it is a composite base. 2 is a prime base. So what do we do to the 4? We take that 4 and we change it to its prime base. How? Take your calculator. 4 is equal to shift, then fact. We get 2 squared. So this is 2 to the power 2. We put the brackets. The x plus 1 is outside the bracket as an exponent. Guys, I repeat this one more time. This is 4 to the power x plus 1. This 4 is a composite number. So we change the composite number base to a prime base by prime factorizing it. This becomes 2 to the power 2. But then there was an x plus 1 on the outside, so we write that x plus 1 as an exponent on the outside over 2 to the power x. Then what do? We take the 2, we distribute by multiplication. 2 times x in the exponent there, it gives us what? 2 to the power 2x. 2 times the 1. 2 times the 1 gives us 2. Over what? Over 2 to the power x. Law number 2 of exponents says when you are dividing same bases, a and a, with different exponents, you keep the base, you subtract the what? The exponents. So what do we do here as well? We keep the base 2 because it is the same for the denominators. Then we do what? We subtract x in the denominator by moving it up to the numerator, and its sign changes to minus. Then our answer is, we now add and subtract the like terms. 2 to the power, what's 2x minus x? When we are adding like terms, guys, we always keep the uniform for our school. These are kids that are wearing the same uniform. They are like terms. We keep the variable x and we subtract the coefficient, meaning 2 minus 1. That gives us 1. But this one, guys, it can be also referred to as an invisible 1. All right? So we can say 2 to the power just x, and then plus 2 we write as a term that is next to the x. So that means our answer is 2 to the power x plus 2. If we come to our answers, which one satisfies the situation that we have here? Is it A? Is it B? Is it C? Is it D? Thank you, Zizi, for the rose. It is C. Thank you so much. Let's move on. Not wasting any time, guys. You see, if you didn't understand, it means that, hey, I'm sorry to say this, guys. Some of you say, I don't understand at all. If you say you didn't understand, guys, then it means exponents for you are a challenge, or they were even a challenge when you were taught, but you did not actually take care of that challenge. So I'm going to repeat it one more time because there's people that say, I don't understand at all. 4 is a base. Change this prime base because it is a composite base. Change this composite base to a prime base. How? Take 4 in your calculator, write it down, press equal in your calculator. Press shift and then press fact. You get 2 to the power 2. 2 to the power 2. So there it is. We are going to write 2 to the power 2 in the place of the 4. But we put it in brackets. Why? Because there's an x plus 1 that is there as well. Are we together so far? 2 to the power 2 raised to the power x plus 1. Over here in the denominator, we have 2 to the power x. It's still there. We take this 2 because this 2 is inside the bracket. This x plus 1 is outside. We take the 2, thank you Z4, we multiply by x. We distribute the 2 to the x, we get 2x. We distribute the 2 to the positive 1, we multiply, we get positive 2, because 2 times 1 gives us 2. So now we have 2 to the power 2x plus 2. In the denominator, we have 2 to the power x. Then, when we look at the situation now, what are we doing? This is 2 to the power 2x plus 2 divided by 2 to the power x. What do we notice? Our bases 2 are the same. So if the bases 2 are the same, what do we do when we simplify a situation where the bases are the same? The law of exponents says when we have same bases and we are dividing, we keep the base as it is, then we subtract the exponents. In other words, this a to the power m retains its positive exponent sign. But this a to the power n, since it's in the denominator, the exponent n changes its position. It goes to the numerator, which means the sign of the exponent n changes from positive to negative. It is now in the numerator. So we have a to the power m minus n, which means here we are going to have 2 to the power 2x plus 2 that stays in the numerator. This x goes to the numerator but changes sign to negative x as per the law number 2 of exponents. Now we can add and subtract the like terms for our exponents. So what is 2x? Thank you for the rows. Minus x, because 2x and x are like terms. We said when we are adding and subtracting like terms, what do? We keep the variable x as it is. Then we add and subtract these numbers, 2 and the invisible 1 that is there. So what is 2 minus 1? That is 1, but the x stays as x. So that means 2x minus x is actually equal to x. This plus 2 is going to be next to x for our final answer. So this is our final answer, 2 to the power x plus 2. That is why when we come here to select our option, option C is the correct answer. It cannot be any other option. Yes, Sine. Yes, Sine. Let's move on to 15. Simplify a to the power negative 1 plus b to the power negative 1. Now, our laws of exponents, we have a law that says when a base is raised to a negative exponent, the answer is 1 over a to the power n. A to the power negative n, a negative exponent will be equal to 1 over the same base a, but changed its position to the denominator. The exponent changes from negative to what? To positive. Where does this 1 come from? The 1 comes from the fact that we have an invisible 1 that is there, which is the coefficient of a. So when this a leaves the numerator and goes to the denominator, the exponent that is negative changes to positive in the denominator, and the 1 that was there gets left behind. That is why the answer now is 1 over a to the power n. Guys, I hope it makes sense. So we come here and look at this situation. Simplify a to the power negative 1 plus b to the power negative 1. So what we see is how many terms do we have in this expression? We have 2 terms, because the plus sign separates these terms. So a to the power negative 1 can be written as what? 1 over a. What about b to the power negative 1? It can be written as 1 over b. How did we get that? We got that because of this law. A to the power negative 1 is 1 over a, whereas b to the power negative 1 is 1 over b. Now what do we have here? We are dealing with a situation where we have to add 2 fractions. When we are adding fractions, what do we usually do when we are adding fractions? We actually do what? We find the LCD. We find the what? The LCD. Between what? Between A and B. So our LCD is what, guys, here? Our LCD is simply what? It is AB. This is the LCD. Now some of you are like, how is that the LCD? Remember, between A and B, what is the lowest common multiple between A and B? It is simply the product of A and B. That's what the lowest common multiple of A and B is. So in order to have an AB in this denominator, what do we need to do to this A? We need to multiply it by B. But remember, what you do in the denominator, you must do where? In the numerator. What must we do to this B in order to make it so that it is fashioned after the AB in the LCD? We multiply by A. But remember, what we do in the denominator, we must do where? In the numerator. Now, what do we have here? We have 1 times B, which is B, that is over AB, plus 1 times A, which is A, over another AB. What do we do in fractions when the denominators are the same? When the denominators are the same, we can finally do the following. We can add the numerators because the denominator is common. Therefore, our final answer that we get is B plus A over AB. LCD means lowest common denominator. Grade 7, you should have learned about lowest common denominator. It comes from lowest common multiple. The reason why we call it the lowest common denominator is because the denominators are what we are checking to find the lowest common multiple from. Okay, so this is B plus A over AB. So that means the answer is actually B. That is the answer. This is the answer for that question. Okay, so exponents are very important. Let's check this one. Next question. Number 16. 2 to the power 2 raised to the power 3 times 2 to the power 3 raised to the power negative 2. Guys, exponents. There's a law in exponents that says if a base is raised to another exponent, what do we do to those exponents? We simply multiply those exponents. A to the power m raised to the power n is actually equal to a to the power m times n. This is an important law. So this law is going to be applied here in this problem. We have 2 to the power 2 times 3. That gives us 2 to the power 2 times 3 is 6 for this first one. Then we multiply. We have 2 to the power 3 times negative 2. What is 3 times negative 2, guys? That is 2 to the power negative 6. All right. Then we have 2 to the power 6 times. Now, some of you now will be aware that, oh, this is a positive, this is an exponent raised to a negative exponent. So that means this law must be applied. So this is actually 1 over 2 to the power 6. But guys, can you see what's happening here? This is in the denominator. This is in the numerator. For multiplication, you can simply cancel these and we are left with 1 and 1. So our final answer, 1 times 1 in the numerator over 1 times 1 in the denominator is actually equal to 1. So our final answer here is 1. What option fits the description? It's B. Now some of you I know would probably have taken your calculator and done the following. Brackets, 2, close the brackets. Thank you, Roe, for the rows. Roe, you are very generous. I really appreciate you. Thank you so much. Some of you could have done this. Exponent 2, exponent 3 times brackets 2 exponent 3 close the bracket exponent -2. Some of you would have done this. And you know what, guys? Calvin Jr., thank you so much for the rose. You could have done this and done this. Voila, you still get the answer. And you know what, guys? That would have been totally okay because it's a GEC paper with multiple choice questions. But remember, if it was requiring us to actually simplify and write the steps to get the answer, we would have to write the steps. But if you do this, guys, it's beautiful. Just put in your calculator, okay, 2 to the power 2, raised to the power 3, okay. I don't know if people are having a tough time not seeing the working out, but 2 to the power 2, raised to the power 3 times 2 to the power 3, raised to the power -2, you can definitely say equal and get that 1. So basically our answer here is B. Okay, you guys will be writing, you'll be selecting and writing your answer like this in that booklet that will be provided if they provide a booklet like in past years. Okay, this is not the actual exam paper, it's a past paper, it's a 2023 paper. Some of you are thinking I'm doing 2025. This is a 2023 paper. We are just using it as a way to practice and remind ourselves of the things we should know as grade 9 paper 1 students. Let's look at this one. X to the power -2 y over 2 -2 x to the power -2 all to the power -3. How do we answer this question? Another law to note: a to the power m, b to the power n, all raised to the power p. If we have two bases that are multiplied together, or it could be two bases that are divided together, raised to a certain exponent, do you know what we do, guys? We take this p, we multiply here, we take this p, we multiply there, which means we have a to the power m times p, b to the power n times p, multiply together. If it is division, we do the same thing. We take the p, it multiplies there, take the p, it multiplies there. So we have a to the power m times p over b to the power n times p. So these are rules, guys, that we utilize in exponents. Okay? It's entertaining one ear and going out the other. You guys are very, very interesting. It's entertaining one ear and going out the other. What in the world of mongrels, guys? I am going to end this live. I'm ending it, guys. Thank you so much for your time. I really appreciate it. I feel like I'm wasting my time. Goodbye. Good luck to everyone who's writing maths tomorrow. I'll see you when I see you. Goodbye, guys. Thank you so much. Wow. What a way to basically say, you know, guy, you are wasting your time. There's 600 and something of us, and we are like, yeah, this guy is entertaining us in one ear and we are not getting anything. Well, guys, that is a great way of saying goodbye. You are not helping us. Thank you very much. Help me, help me, help me, help me. I need your help. You're not wasting your time. Okay. All right. No. All right. I just wanted to see that. I wanted to get that validation. Okay, so let's go, guys. Thank you for the roses. Okay, so it does mean there are some people that are listening and they are really benefiting from this. Okay, let's take it through then. X to the power -3 y over negative 2x to the power negative 2. So if we look at the numerator, we can apply this law here for the numerator and the denominator, because the relationship, guys, x and y is multiplied, we are dividing by 2, and x, that is negative. We have a negative 3 here, that's an exponent. So what I would do, maybe myself, you can do this in 2 ways, okay? You can do this in one of 2 ways. If you look at this inside the bracket, you could simplify what's inside, then apply the negative exponent later. It's really up to you, okay? Sorry, there's one more law I want to write down. If you have a over b, that's raised to a negative exponent. What you can do as well is you can flip these two around. You change the sign of the exponent to a positive exponent n. Okay, a over b raised to a negative exponent can also be b over a. You take the denominator, it becomes the numerator becomes the denominator. You change the sign of the exponent from negative to positive. This is another important application of this rule. The idea that if you have a negative exponent, you can simply change the position of the base and then you change the sign of the exponent. The inverse operation. I love that, okay? Okay, I hope you understand. So these are important rules, guys. Important rules to note because they will help you when answering questions. And they will help you very well when answering questions. So if you are able to actually apply the rules, guys, you'll be winners. You'll be winners for days. So if I'm looking at this question, I'm thinking of one of 2 ways. I could change. Hey, calm down my background. Guys, unfortunately, I can't.